Hello, so this is part 2. So in this video, so last time we discussed that our conserved charge Q really should be the sum of 6 independently conserved charges, where 3 of those charges are associated with boosts and 3 are associated with rotations. So in this video, I'll just do the rotations. So the first thing I'll do is I will write our expression for the conserved charge. So I have this new contracted here. And whenever I have contracted indices, it doesn't matter if which one is up and which one is down. So I'm free to lower this new as long as I raise this new. So I can get this expression before our Q. And the reason I want to do that is because we know that our omegas with 2 indices lowered are antisymmetric. And I'll be using that fact a lot when we discuss rotations. So I've just rewritten that up here. And then I've written, so again, we should be able to write our total conserved charge Q as a QB, where B stands for boosts, and QR, where R stands for rotations. And each of these two things will contain 3 terms themselves. But let's just worry about how to divide this up into boosts and rotations. So the way we're going to do that is we can notice that what we have here is our omega matrix doubly contracted with this matrix. So if I have, we'll take a little detour here. So if I have our omega matrix contracted with some matrix like this, which is what we have, I can write this out. I can split this up into the different sums. So first I will split up this sum over mu into the spatial part plus the the time part plus the sum over the spatial parts. So I've done that here. And next I will do the same thing for nu. I will split it into the sum over the spatial parts and the time part. So, okay, so I need to rewrite this here. 0 and 0. So I will get this expression. And you can notice one thing immediately is that for any omega we have, regardless of the boost that we're talking about, the diagonals, or the transformation that we're talking about, the diagonals for all of our transformations were 0. The omegas had 0 diagonal. So since we have an omega 0, 0 here, this will just be 0. So I'm left with these 3 terms. We know that, though, for our omegas for rotations, they only involved the spatial parts. We had no, all the, the elements that were in the time parts were 0. So for rotations, omega 0i and omega i0 are 0. So if we're only worrying about rotations, we can just write our omega mu nu as omega ij, and just just worry about the spatial parts basically. So knowing that, I will just write our QR as this, and I'm using J and K as Latin summing indices, meaning I'm just summing over the spatial parts. So now I have, again, omega is antisymmetric in J and K, and this is not necessarily symmetric or antisymmetric, but I know I can write any matrix as a sum of symmetric and antisymmetric parts, like this. So this part is symmetric, this part is antisymmetric. Clearly, these two things are equivalent, so I'm free to write this matrix as this. And then we can make use of another fact, which is if I have an antisymmetric matrix doubly contracted with a symmetric matrix, then I can play our game as usual and prove that it's 0. So the first term I'll have our antisymmetric omega jk contracted with the symmetric matrix, and that will be 0. So I'll only have to worry about the term here. So I've written that out. And so again, we should expect, so this is our Q for rotations, but we expect that this can also still be written as a sum over 3 terms, 1 for each rotation. And the way we can do that is basically any antisymmetric matrix can be written as a sum of 3 basis matrices. So the 3 basis matrices being epsilon 0 jk, epsilon 1 jk, epsilon 2 jk, and epsilon 3 jk. So I'm just going to write omega jk as a linear combination. So the ci's are just constants. And I've just written as a linear combination of our basis matrices. And I can plug that expression in to our QR here. And so that will tell me that the ith, so that will be what we want. It'll be a sum over i's. We'll have 3 terms, 1 for each I. And the ith term will look like this. And again, our QR will be the sum over I of these 3 terms. So since in this expression I'm not summing over I, I'm free to, the CI is just some number. So I'm free to just divide it out, define my conserved charge to be this. And this is the expression that David Tong has in his notes. So yeah, we're finished with rotations. Next time will be boosts, where we'll have to deal with these 2 terms.